Okay, let's give this a shot. Let me grab all your screens here for a second. There we go. All right, I want to talk about file stuff. So the first thing I have to do is what? Create a file. So we're just talking about having 10 numbers in here, so I'll make them easy to recognize. Let's see. Numlock, that's going to help. All right, so there's 10 numbers in there, and I'm going to go ahead and make sure, when you're doing this, make sure you don't have any blank lines at the bottom, because that's going to mess you up. A couple of you have had problems with stuff just because you had blank lines down there at the end of the file. So always hit the down arrow as much as you can and then backspace until you get back up to your numbers here. So I'm going to save this as my H drive, so there it is. I'll just call it numbers.txt. And yeah, I want to get rid of them. All right, so then I can close that. So when we open this up, it should be obvious what we're doing. So I'm going to say in file, open. Now, I don't think the discussion is going to last for a long time today, so you can get some stuff done on other stuff that you're working on for in here. So this is going to be H // numbers txt. So I want to open that file. I want to make sure it opens. So anytime you open a file, make sure it opens just by doing that. So now what am I going to do? I want to read these in, so I know how many are in the file, so I can say for x equals 0, x is less than, let's do this right. Let's come up here. I'm going to say constant int size equals 10. Okay, notice my size is all caps. That's tradition. And so now I'm going to say this. I'm going to say, I could say size right here, couldn't I? Maybe make it all caps too. And I can say size right here. Size. All right. So I'm just saying, let's loop through the whole thing, through the whole array, and down here I'm just going to read these in. So I say in file. Now normally we put a variable there, so that's what we're going to do here. I'm going to put nums bracket x. So as x changes from 0 to 1 to 2 to 3 to 4, that good stuff, the slot number will change. That's what we want it to do. And so then I'm going to, that's it for reading the stuff in, so I can say in file, close. Now notice, if I had if size, if I want to change that to 1,000, all I got to do is change it right there, and then it'll change this loop from 0 to less than 1,000, and so on. As long as my array will hold that much, and as long as there's that much in the file. All right, so I want to, there's my curly brace. Now what? Well, I probably want to print them out. So I'll just say for some kind of loop, x equals 0, x.
Do you still want it in that?
Yeah, couldn't you just do it inside the other loop?
I could, but I'm going to get all my values, and then I'm going to get all of them, and then I'm going to print them out. So as much as possible, you know, if you're thinking in terms of functions, because I don't have any functions in this yet.
No, but I mean, like, put it inside the if statement, because, like, if the file doesn't open, it's still going to process that.
Well, right, you're right. Right here, I'm going to get junk if it didn't process, right?
Yeah.
So we ought to be able to tell pretty easy. But yeah, if I were doing this for real, then I would put this inside there too, which wouldn't be very hard to do at this point. Here, you know. So C out nums x. Okay, now put my curly brace back. And we ought to be good. I put void main here. Will it compile? What's it not liking?
I don't think you put the x plus plus in the second for loop.
Okay, right here. You're right. Thank you. Okay, let's try again. So I get a warning about main being void, and there's my numbers. So in the text, when you're reading about it, that's all you got to do. Now then, that's if I know how many things are in there. If I don't, then I've got to change things up a little bit. So instead of this kind of loop, what am I going to do?
No, just a while.
All right, so I can say while not end of this file. Actually, all I got to do is that right there. Right?
But then wouldn't you have to change the size of the array?
Why?
Because if it has more stuff, if the file has more numbers in it than the array has places for it, then it won't
You're right.
work.
You're right.
That's what the vectors for.
And that's where the vectors are going to come in, Gracie says, and she's right. Because see, once we get to vectors, we can say, oh, vector get bigger if you need to. So right now we know there's 10 in there, but just if I wanted to run it, and it's still not happy with me, what's it saying now? Uninitialized local variable. Oh, so x equals 0. Oh, I got to do some more stuff, don't I, since I'm using a while loop. I got to take care of this inside the loop. The for loop was doing that for me. Yeah. Okay, and once again, it reads the numbers in. And Brenda's right. If I had 1,000 numbers in there, it's going to fill up my array, and then then what?
It would just take the first 10, right?
Yeah, but look.
Would just be trash.
But look. Once I get past the first 10, what am I doing? We talked about this the other day. I'm saying store it someplace. Where's it going to be, Mark?
It'll be in the end of the array.
How so? Where's that 1,000th number that I'm reading in going to go?
I honestly don't know.
You what?
I don't know.
Luke, help us out. Not to put pressure on, but we talked about this Tuesday. I know you're getting older and your mind starts to go, but see, it's not there. Okay, Gracie.
It's going to go, I'm going to watch the way I described it. It's going to go in the next thing like the next thing it's called from the, yeah, it's going to go in the next spaces in memory.
Yeah, it's going to go in the next spaces in memory. Just hold on just a second. Let me show you. Get the white screen here. The way this works is the way a program is laid out in memory, in actual RAM. You've got your date at first. and there's a little segment for data, and then you have your code. This is where your actual code is. So here's where you declare your variables, and then your code comes after it.
So if you declare variables in the if statement, and like if you declare like local variables, is that going to be in data too?
They're stored in another place. Yeah. So I've got my data, and then I've got my code. And then if I do this, and I'm storing values here, what comes right after the data? Your code, which means you're storing stuff on top of the code you wrote, all these commands, just random numbers coming out of a file. You're trashing out your program, not just the data, but you're trashing out your whole program.
So just what happens? Like you say you're trashing out the program, but what does that mean?
Where does my code actually start? Right here on line 14.
Yeah.
So that's getting translated to machine language. I'm overriding that machine language with stuff coming in from a file.
Yeah.
Yeah. That means the commands are getting overwritten of my program in RAM. I can tell from that, okay, that you're going, yeah, I don't get it, but okay.
You're not explaining what happens when it trashes out locally.
Like you're saying that it's getting like with the extra values, and you're saying that it's like overriding the other commands. But what does that mean?
Hold on just a second, I'll show you. I'm going to pause. All right, so we're back on. This is what stuff looks like in RAM. If you could look in there, notice each one of these little pairs of numbers is a byte. So here I've got 7573 696E. That's in base 16, which we don't really get into in this class, but you will if you go on in programming. So this is called hexadecimal, base 16, and here's what data and code look like in RAM. Well, what if my data is up in here? That's not writing very big. Let me make it thicker. What if my data is up in here, and all of a sudden, and my code, my actual programming commands are down in here? What happens when I start filling this up with stuff from the file? What am I coming down into? My program. The commands of my program.
Okay.
Because this is what your program would look like once it's translated.
So like that makes sense.
Okay. That's what?
That's usually all the others.
Yeah, see, these things over here, these numbers are, again, in hexadecimal. These are addresses in RAM. Notice it starts at 0, and we're up to 496, but that's in base 16. I don't want to get into base 16 because we don't have any need to in this class. If you want to talk to me about it, get with me, and I'll sure discuss base 16 with you, because it's kind of fascinating. But don't need it in this class. So all I'm saying is, if you go past where your data is stored by doing something like I was doing, then you're trashing out your program. Let me erase that. So this, if I did this, let me change the size. Let me show you what I'm talking about. Let me change the size to 5. And the beauty of this is I don't have to change anything else. What's going to happen? Let's run it. Hi. Everybody's here. Thank you. Here's what I'm getting. Crash. You know, we saw this Tuesday. It's, hey, you just overflowed something. And when you play this video, you can see what this really says. It says stack around the variable nums was corrupted. So, crash time. So abort the program. And we're back to here. So, yeah, if you're doing a while loop and you're going all the way to the end of the file, make sure you're using a vector, probably. Okay, questions about that? Stuff you got to watch out for. Bounds checking. What is that, Caitlin?
It's where it checks like how many numbers there can hold it.
Okay. So what are my slot numbers for this one? If I go back up, you're right. What are my slot numbers if I go back up and say 10 here?
It's 0 through 9.
Right, 0 through 9. So we as programmers and humans go, okay, 0 through 9, that's what I can use, but the compiler doesn't help you out there. We just saw that with that for loop. It just goes, or this while loop. Okay, I'll store it in slot 1000 or 999 if you want me to. And yes, that might be crashing your program, but here you go. Do you really want me to store that lit match in your gas tank? Not good. Not good. All right, so that bounds checking thing is real important. You have to do it. Other languages like Java tend to do that for you because they're, C++ was for professional programmers, and Java, even though it's used by pros, really wasn't designed for that. What if I do this? What if I do this? I've got my 10 numbers in there. What if I do that? I change the 0 to a 1. What went wrong? Rohan?
So it's the off by 1 error.
Off by 1. And this happens all the time. And then, I'm sitting there eating a corny dog or something, and you email me and go, Ladley, the computer's broken. It's only printing out 9 of my numbers. God hates me. And it's really just this off by 1 error here. This is real easy to do. And one reason that it really helps to come up here and declare a size is you probably won't make that error on the top side because of this. So, something to keep in mind. Here's one. Let's say okay, I'm going to scratch this. I'm not going to read these from a file anymore. And I'm going to say, we'll just say size equals, and so I'm going to initialize this to something that should be pretty easy to see if we got it right. 1, 2, 3, 4, 5. So I've got 9 numbers in there. So that leaves 1, doesn't it? So we'll put 20. Okay, and now I've got another array. Son of nums. That's right now just got junk values in there. And I go nums2, nums, equals nums. Because it makes sense to us, if we got one variable called y and one called x, I can assign y's value to x, or vice versa. And the compiler's already screaming at me before I even try to compile it. And look what it says. Must be a modifiable value. What does that mean?
It means like a variable.
You can't modify the beginning, what's it called, address, the beginning
Yeah.
They need to bring it.
Yeah, what is that right there?
The beginning.
It's an address. And so if this address is 1,000 and this one's 2,000, you're saying store 2,000. Well, that's not a variable. It's a literal address. I can't modify that. And so the compiler won't even let me try to run this program. So what I have to do, and this was one of the questions earlier, is to say for, I've already got x up there, so for x equals 0, you start at the bottom slot if you want to copy the whole array, and x less than size, x plus plus, and then down here you say, okay, there's my array, what slot? Well, slot x, and I want this one to be slot x. And now I'm good, because you're saying take the thing out of slot 0, when x is 0, take the thing out of slot 0 and nums, copy it into nums 2 slot 0. Then x changes to 1. Take the thing out of slot 1 and nums, store it into slot 1 and nums 2, and so on. That's how you do it.
That's crazy.
It is, but we live in a crazy world.
Whoa. That's just a lot. Is it?
And we're back. So what if I want to print this out? What if I want to print my array out and I say cout, oh, I'm in this thing. And I say cout nums. Thinking, well, hey, nums is an array. It's a thing. I can print anything out. What's going to happen, Hannah? It'll print out what?
The memory address.
Let's see. She seems to think it's going to print out an address. But instead, it prints out this address. Now notice this is base 16 again. So I've got some letters in there, F's and E's. So from that standpoint, I could print out nums 2.
Well, it would just print out the address.
And look, it's a totally different address. This one's way off from that other one. So see, these are not next to each other in memory. This one's way off. Look at that 3. What did we have before? A 2? Oh, we can, not a 3. Let me do this. Nums, I'll put nums here. And then a little space, maybe. And then nums 2. Trying to do it right.
No, it's just going to print out that two address.
It is, but I just want you to see something. Notice,
I was like, what is?
now those are pretty close. Whoa. Those are pretty close.
That was a different.
They did change. Why, do you think?
Because you moved it.
No, because you recompiled it.
I recompiled it, and that means my program loaded in RAM in a different spot.
That's insane.
We're living in an insane world. Here it is the third time. See, these are pretty close.
Yeah.
Every time you compile it, what are you doing? You're saying, hey, Visual Studio, compile this program and then call Windows to run it for me. Well, when Windows gets that call, it loads your program into the RAM that it decides on. You don't know ahead of time where it's going to go. These computers have 8 billion bytes of RAM, which means it could be anywhere in there.
Does RAM go from the beginning to the end?
It's up to Windows. It's up to the operating system. And Windows will reserve some of that for itself to keep track of things. You just don't know. So, okay, that is, how do you print them out? Well, like we've been doing with a for loop. And that range-based loop, that if some of you fell into that quagmire of reading that, it won't hurt you emotionally, I don't think. But the only time that's really useful is if you're in main. and then that works like a champ. But once we start sending arrays as parameters, it's not going to work out very well. So I just didn't even have you read about it. If you want to, go ahead, but I mean, it's not going to hurt you. Last thing was, we got a couple of things. How do we get the average?
Oh, you create like
You
a.
have a accumulator variable and then divided by the
Let's do that. I'll just leave my numbers the way they are, and I want another variable up here called total. Why do I need that, Claudia? Claudia?
What?
Why do I need that?
I don't know.
Well, what's your best guess?
I don't know.
What was the question?
How to find the average, but I thought you.
Yeah. And I
I
said,
had averages, and you add all the numbers up, and you divide it up by how many there are.
and so I said, why do we need a total variable? Was the question.
Oh, so there's like something that you can add to so for the total.
Mm-hmm. So I'm going to come down here now. If we had 10 different variables, what would I have to do? I'd have to add each one individually to the total. So that's going to take at least 10 lines of code to do. But with a loop and an array, I can say, for x equals 0, x less than size, x plus plus. Now here's the thing. When you're dealing with arrays, say, what would I want to do the first time? Well, I'd want to take total and add it to what? Nums 0, right?
Yeah, you can put X. You can put X.
Yeah, but the first time I'd want to do this. Would you agree?
But you can put X so you don't have to do it multiple times. I mean, yeah.
Claudia, I could not agree with you more. I mean, I'm totally agreeing with you. I'm just saying, when you get into this array kind of stuff, if you're having trouble with it, say, what would I want to do the first time? And I'm saying, I'd want to take the first one, add it to total, and then stick it back into total. Once you've got that, then substitute whatever number you put here for, just like Claudia is saying, X. Now notice, y'all, what if size was 1,000,000?
Well,
Just change the constant.
If I had 1,000,000 things in an array, 1,000,000 integers, would that loop with 2 lines of code add them all up?
yes.
Yeah.
Is that adding?
It's adding each one to total. Total is keeping a running total. And so then I can print that out. Now, what if I was getting the average?
After the loop, you do total
You
divided
divide
by
by
size.
You do that, and then you do total divided by size.
X. Add numbers X, right?
No.
So I could say
It is.
double average equals what?
Is it
Total divided by size.
Yeah.
Oh, wow. Yeah.
Okay, so in the book, it talks about how do you add up a bunch of stuff. There's how. There's how you get the average. All right, last thing. No, it's being recorded. You can take a picture if you want to. We can get wallet-sized ones made.
Oh, that sounds fun.
Yes, yes. Somebody sees you in your purse or wallet or something. What is that a picture of? It's some C++ code. It's,
Didn't they really think I was
then, yeah. Before they thought you were weird, now they're going to be convinced. All right. Let's mix these up a little bit. Let's make this 20, and this -3, and this 0, and this 50. We'll make that the big one in there. And this one -6. This one 17. And we'll just leave those where they are. Now, what if I wanted to find the largest?
You do the king of the hill thing.
Great. And so I'm going to, let's get the whiteboard back here. So y'all can make fun of my handwriting. The day's not complete without that. Okay, so how's it work? What's the algorithm?
You do the first one is the largest.
Okay,
The system.
Oh, that's fine.
the original king, not king, the con king is the first one there.
Yeah. And then you compare the second one to the king.
All others compared to who?
The king.
Which king?
The
Thank you, current king.
Yeah. The that one.
And so if I had a bunch of individual numbers, I would have. If I had 10 individual variables, I would have this thing up here being taken by the first one. The king is whoever the first one was, and then I'd have 9 if statements, right?
Or you could just do a loop.
Or you can just do a loop.
Not with individually named variables.
How do you do it
Well, you don't.
without doing all that?
In other words, just to make sure we're understanding this, if I had 3 and 6 and 5 and 4, if I had that, then I'd say king, I'll just abbreviate, equals this, the 3. And that'll be a variable. And then I'd say what? If
If
6 is greater than king, then king is,
equals 6.
yeah. And I'd do the same kind of thing if I'd have another if statement that if 5 is greater than king, and 5's not because king is now 6. And so I'm just doing the algorithm. Each one of these following compares against the current king. If I had 10 variables, I would have this statement here and then 9 if statements. So let's go back to this. What do I do here? If I'm looking for the largest, int big, or king, if you will,
Yeah.
equals who?
Equals num0.
Good. Bad. See if I can type today. There it is. Num0. Now what? 4. X starting where?
1.
Yeah, because I've already taken care of the 0th place. And then x less than size. Now, if you accidentally put a 0 there, it's not going to hurt anything. And then x plus plus. Now what? If nums x.
Greater than king.
Good. If that's true, did it just freeze up on me?
If done.
Kinga. All right, if that's true, now what?
Then king equals num x.
Beautiful.
You need another parenthesis.
Yeah, you need that.
That one doesn't even belong there, does it?
Oh.
Okay, so unless I made another mistake, we're good. Now, y'all, think again. How many lines of code did this take? Well, 4 if we count everything. What if I changed this to 1,000,000 and I had an array that had 1,000,000 things in it? How many lines of code now?
Would still be 4.
Right, and that's the power of combining arrays with loops. So if we ran this, I'm just going to print out the big one here.
But it just allows mine to understand it and then how to think about it.
I forgot what?
Curly braces.
Don't need them. There's only one thing happening in the if statement. And the if statement's the only thing happening in the loop. If you want to put curly braces, I sure don't have a problem with that. It might make it easier to see, but I didn't need them here. So if I do this, and it prints out, the king is 50. Anybody have a question? Because I want you to have some time, like I said, to program. You have a little bit. Okay. That's it for me then. Rook, you going to take a picture or something? Okay. Did you see those others online?